In this video, we're going to look at how to take the given components of a hyperbola, like its center and its vertices or its foci, and then figure out how to write the equation based on those pieces. As with the other shapes, I have a long list of rules here, and again, I've just repeated the standard form for reference while we're going through this. The first thing I always do when I'm asked to write the equation with some components is to take whatever pair of points I was given and find the center of the hyperbola. Just like with the ellipse, start off with the center by averaging the x-coordinates and averaging the y-coordinates. It does not matter what the name of those points is. If they gave you the foci, the transverse axis endpoints, or the conjugate axis endpoints, find the midpoint. That'll be the center of the graph. Next, I take the distance from the center to either one of those points they gave us, and then identify that length, whether it will be A, B, or C. The variable you tie to it will be based on the name of the points they gave you. If they said transverse axis endpoints or vertices, then it's A. If they said conjugate axis endpoints, then that length you found is B. And if it's the foci that they give you, then that length is C. I always associate C with focus because there's a C in the word. So find the length from the center to the midpoint, or from the center to the point they gave you, and then figure out which variable it is. Next, I look at the points that I was given again. If they were the transverse axis endpoints, then you want to note whether it's the x-coordinate or the y-coordinate that's changing for them. If x is changing, then that would mean A and x need to be paired together. So A should be underneath x, and it would mean that x needs to go first, because A always goes first. If instead they had given me the conjugate axis endpoints, then again, look at what's changing for them. Is it the x-coordinate or the y-coordinate for the conjugate axis endpoints? And then if it's the x-coordinate changing, that means B goes with that variable. B goes with x. And then that would mean that those go second, because B always goes last for the hyperbola. Next, if you are given an axis length, they may say the transverse axis length, that's from one of the endpoints to the other. But since our A, B, and C values are determined as the length from the center to the endpoint, make sure you divide the number in half to get your A or B value. And perhaps the trickiest thing for hyperbolas, sometimes they will give you the slope of one of its asymptotes. And that number will either be A over B or B over A. The way you'll know is by looking at which type of hyperbola you have. If it's a hyperbola where x comes first or y comes first, you'll be able to distinguish between these two cases. So the slope they give you, if it's a slope of 2/3, write 2 over 3 equals A over B if y comes first in the equation, or write 2 over 3 equals B over A if x comes first. These numbers changing, that comes from the fact that slope is always rise over run. Hopefully you remember that from algebra graphing. So when you're looking at the number underneath y and the number underneath x, since the number under y always has your vertical motion, that's how you'll be able to say, okay, well, rise over run would be B over A, or the other way around, the number under y is rise, so A over B. So rather than a formula, I usually just pay attention to the y number and then the x number for numerator and denominator. So now we'll look at some examples with this. So here's our first example. We are asked to write the equation for the hyperbola, and they've given us 2 points here, the foci, 0, 3 and 0, -3. That's just their lazy way of writing the 2 points. So to start off, we want to find the midpoint of those two coordinates. Well, the x-coordinates are 0 for both. So you would be doing 0 plus 0 divided by 2. And then -3 and +3 are the two y-coordinates. So you would add them up and divide by 2. That would give you the midpoint or the average of the x and the y values. 0 plus 0 divided by 2 is 0. And -3 plus 3 is 0. Divided by 2 is 0. So that's the h and the k value we'll be using. Now that I've found the center, I said to also take the distance from the center to one of the points they gave me. Doesn't matter which one you pick, either use 0, 3 or 0, -3. From 0, 0 to 0, 3 is a length of 3. Whether it's A, B, or C, that's based on the fact that they said these were the foci. So that means the C value is what's equal to 3 here, because the distance from the center to a focus is 3, and that's what we just determined. From the center to a focus, that's the variable C. The next piece of information we were given is the transverse axis length. But again, that's from one endpoint to the other, and our variables are based on the distance from the center to the endpoint. So the transverse axis is tied to the A variable, but make sure you cut the number in half since we just want to go from the center to the end, not from end to end. So now I know A, C, H, and K, but I am missing the B value, which I do need for writing the equation. So the formula for this is A squared, and now it's a plus B squared since the hyperbola has a minus sign in it. So A squared plus B squared equals C squared, which is 9. So if you subtract 4 from both sides of the equation, then that will mean B squared equals 5. You could go on to find that B is the square root of 5, but that's not necessary because the setup for my equation is going to be using B squared anyways. I'm going to have to go right back to the B squared value. So the trickiest things here are for our two fractions. We know that it's going to be a minus between two fractions. The equation is always set equal to 1. We know that A always goes first, A squared rather, and we know that B squared always goes second. But to figure out whether X or Y goes with one or the other, we have to look at some of the information they gave us. A and C always go in the same directions, and since C has the Y coordinate changing, that means A and C should both be paired with the Y variable. So that means Y comes before X. A and C always go in the same directions, and for a hyperbola, A always goes first. So since C goes with the Y coordinate, A goes with the Y coordinate, and that means Y goes first. So that's it. That's our equation right here. Okay, here's another short example, but this time we'll have the center with a different location. This time I was actually given two different pairs of points, so it doesn't matter which pair you pick for finding the center. It's whichever one you think will be easier to work with. I'm just going to pick these for finding the center since they were given to me first, but it doesn't matter. So if I average the x values, I have -3 and another -3, and I'll be dividing that by 2. And then I have a -8 and a -2, and I'll be dividing that by 2. So -3 minus 3 more is -6, cut in half is -3. And then -8 minus 2 is -10, cut in half is -5. And these would be the same values you would get if you had picked the other ordered pair as well. So now that I know my H and K, I want to go through and figure out as much of the A, B, and C stuff as I can. So the distance from -3, -5 to -3, -2, the x coordinates aren't changing, so I can just look at the y's, and I see that from -2 to -5 should be a length of 3. The variable I'm going to associate with this, since these were the transverse axis endpoints, well, the distance from the center to a transverse axis endpoint is our A definition. Now I have another pair of points. I don't need to find the center of these again because it would be the same number I already got, but I can do the process of saying what's the distance from the center to either one of these points I was given, because these have a different name. These are the foci now, so I could figure out C from that. So from -3, -5 to -3, -10, or to -3, 0, whichever you prefer, that's going to be a length of 5, and the variable associated with foci is C. So now I need to use my formula for finding B again. I'm going to have A squared plus B squared equals C squared. And then if you subtract 9 from both sides of the equation, that means B squared is equal to 16. So I could go on to say that B is 4, but I don't need to. I'm just going to stop there because B squared is all I actually wanted. And then when I go to set up my equation, I know it's going to be a number, and then there's a minus sign and another number, and then this always has to be equal to 1. I know that A squared always goes first, so if A is 3, A squared is 9. And then this is B squared, so I can just put 16. For figuring out which variable to put first, X or Y on this, just look at where either your transverse axis endpoints or your foci showed the change. So since it was the Y coordinates changing for the transverse axis endpoints, then that means Y goes with A, so Y needs to go first. You could have done the same thing with the foci. You see that it's the same information, it's that the Y coordinate is changing. So if C goes with Y, so does A. So either way, you get the same result. So my equation is going to be Y minus -5, or Y plus 5 squared, and then the X value. So X minus -3 is X plus 3 squared. One last example, this time we were given a pair of points and the trickiest case, the slope of one of the asymptotes. So we'll look at that. First, I still want to find my center. So averaging the x's, -1 plus 5 divided by 2, and then 5 plus 5 divided by 2. 5 minus 1 is 4, cut in half is 2. 5 plus 5 is 10, cut in half is 5. So here's h and k. And again, I can take the distance from the center to one of those points. From 2, 5 to 5, 5 is a length of 3. And those were transverse axis endpoints. So that's the variable a. Now here's the tricky part. I know that from my equation, the transverse axis endpoints are showing the x coordinate changing. So if I think about what my setup is going to end up looking like, I already know that I need to put x first because it's the x coordinate changing for the transverse axis endpoints. So I know it's going to be an x minus something squared and then the y minus something squared. Well, based on the fact that x is coming first, I know that a squared goes down here, and that means the number underneath y is going to be the b value. So the rise for my asymptote is b, so I need to say b over the run is a. So for figuring out rise over run, it's the number under y on top of the number under x. So b over a in this case. And the slope of the asymptote they gave me was 4/3. Well, this one's nice and easy because if I plug in that a is equal to 3, so I'm just doing a little substitution there since I already know a, you can multiply both sides of the equation by 3, and that means b equals 4. Sometimes you will have different numbers for the denominators, so you might have to do some more solving, cross-multiplying, whatever you want. But in this case, now I know right away that b is 4, so b squared is 16. And then we'd already found the h and the k numbers, so I just need to show that it's x minus 2 and y minus 5. So the trickiest thing was knowing whether we write b over a equals the slope of the asymptote or a over b. And to reiterate, you just do the number underneath y on top of the fraction. So figure out whether the number under y is going to be a or b. Put that one on top either way. So that's it for writing the equations.